So welcome to Raymond Lowe, Intel. He's going to speak about building your chatbots with OpenVINO and AIPC.
Perfect.
Raymond, thank you. Welcome. Thanks for being with us today. And you have 25 minutes plus 5 minutes Q&A, and the floor is yours. Thanks so much.
Perfect. Thank you again. I'll have a lot of slides, so bear with me with the slides today. My name is Raymond. I'm from Intel, and I've been with Intel for the last 5 years, almost 5 years. So if you're interested in what we're doing, follow me or our team on LinkedIn. You'll see a lot of news about what we're doing at Intel. So oftentimes you'll see a post from me before there's an announcement somehow. So for example, I work on OpenVINO a lot. So a lot of pre-release material, sometimes I test it out and you can see it. But to no further ado, let's talk about chatbot. People call it agentic sometimes. For me, it's really about how can we talk to a computer. And today we'll talk about that because having a machine talking to you was not easy. And when it does, it's very powerful. So let's think about journey as yourself. I've done a lot of different programming exercise since I was young. But one thing really intrigued me today is we can really have a good interactive experience with computers. I remember the first time when I get a computer, you get a mouse and keyboard, you click on it, type some document, it feels good. But what if we can have a proper conversation, and what that brings is an experience like going to the hospital, for example. How many times you walked in, you're trying to figure out, okay, who should I talk to? Where's the nurse, right? And then oftentimes you go in there, the nurse may ask you, why are you here? And then, of course, we're sick. Of course, we are not feeling comfortable. At that time, I think if we can reduce some of these wait time, I think there's a lot of huge benefit from building such chatbot or assistants, we call it sometimes. And my brother's the doctor, right? We saw a lot in efficiency in the system, like especially for note taking and things like that. So as we see today, this is becoming a reality. I see, actually, when I see the doctor last week or a couple of weeks ago, I walk into the office, I saw the person already turn on the cell phone on the edge, recording our conversation, transcribing, and making a better experience when things are needed to pay extra attention to. I think to us at Intel, this is a great opportunity because your PC, what's sit in front of you, could be the best companion. And why I think so is they're not just talking, right? The chatbot, of course, you can do large language model. When I first started, I thought Llama 2 was like almost Asian time, but it was not answering great questions sometimes. It was like off track, hallucinating. But today, if you look at what Microsoft released, for example, 3.5, they can answer better questions even with images. So imagine now you put the questions about like what's happening to my eye. They actually can do better. And we saw just last week I was at Microsoft Build, we saw scientists are using these tools for discovery and more and more. And that's why I think about chatbot is just really like, how can we have a better way to communicate with computer in a deeper way, right? Think about even doing research and thought processes. And for consumer, I don't know if anyone have babies here. I do have a baby, and it's 1 year old. And the number one question I get asked by my wife a lot is like, what's my baby doing? And imagine we can have smart camera that you can set up without coding. All you need is put like a large language model behind it, like with a visual language model. And then you can have questions like, oh, my baby was trying to play with the computer, play with the keyboard. And that's something actually we're seeing on the edge. It's like, hey, we can actually make extremely smart computer without a lot of like computation power it takes. May not be very, very accurate, but we're just the beginning, right? And then how much more we can get within a year, that's something worth thinking about. And one thing I think a lot of us, like when we build a lot of assistants on the edge is you never have that big enough model. You always have a small model that actually can fit into the memory. You may have like maybe more limited reasoning. So we also see the next generation is more like agentic with RAG on top. So why that's important is we test a lot of these. For example, in this case with Llama 3, 8 billion, it works extremely well for, let's say, simple use cases. And when you have RAG, which allow you to augmenting information to the chatbot, like for example, ask what's AI PC here. It will not know it if I didn't give you the document, right? So, and it's important in the edge use case. Maybe sometimes you want to provide extra information, so then it actually be contextual aware. Think about you in a restaurant. You want to build something that with your burger menu, and we can do that now. We can do it extremely well with RAG and also some agentic chatbots. To the very final piece, when we think about compute at Intel, we've been supporting a lot of different models. And then again, I talk about OpenVINO, I haven't introduced it properly. But what we notice is we accelerate some of the work so well that only a couple of years ago, or a year or two ago, these are not even possible locally. So what you're seeing on this computer right now, which I capture on my own machine, I'm running one of the image generation on the local GPU, the iGPU. I can generate this beautiful teddy bear in about 8 seconds. 8 seconds, like finally, like a beautiful teddy bear that's faster than any human drawing ever. And the quality is as good as some of the photography I took myself. So that's very intriguing. And the same source code, if you upgrade your GPU, I don't know you ever followed the Intel Arc trend. I'm the fanboy. That thing is a beast. It has 16 gig of RAM. It actually, like a couple of years ago when it released, actually, we start building AI examples on it, and then we realized they're super powerful for the price point we're giving. So that's another great example how we see programming like a chatbot or creating very interactive material on the edge. And the GPU you have today on your laptop most likely is sufficient. And in this case, we can finish this in 2 seconds, as you can see, very fast. So this brings to the very important question is like, what is happening at Intel, and then what happened to some of the work we have done? This is very new, by the way. I just released this last week. We talked about a Microsoft build. We are now collaborating with many great customers and partners. And then one thing we collaborate on is a lot of software component that you may not have heard about today until maybe now is Microsoft released something called the AI Foundry, or we have the Windows ML. What we have done is actually we have put some of our technology, for example, OpenVINO, quantization here, you can see on the left. And then also we provide our runtime to the Microsoft ecosystem. So later on, when you buy your PC from, let's say, Best Buy or some other, maybe Costco, it will preload OpenVINO for you. And when you download your model, you will get the best performance out from it. I think this is a life-changing for me. When I started at Intel 5 years ago, we joke around it, right? Why don't we have this pre-installed at Windows? I think it's not a joke anymore. So it's happening as we move forward with, let's say, the new way of thinking about building software on PC, especially on the AI front. The model will be pre-compressed for you, and then we'll have a runtime that always ready, so you get the best performance out from your silicon. So, and this is something I spent 2 to 3 weeks to get from our engineers. So if you really wonder how it works under the hood, I bring it to you. So my background is software engineering. So when I see diagram like that, it makes me happy. Feel free to take a screenshot of this. So this is under the hood. Come to our webinar, we'll talk about this further. But for now, I think this is a great example how deeply we integrated into some of the work in Windows and others. Of course, our work works on Linux as well, if you're interested in having portability. So I talk about a lot of benefits. I talk about why we're here, why we're in the edge. But what's OpenVINO? Why are we here talking about this? And why do I promote this? So think about all the great examples you saw can come from different models, right? We can have PyTorch. We still have some TensorFlow model coming in. For example, some of the old school gesture recognition stuff was from TensorFlow. And we have AllNext, of course. We have even Paddle from China. All these models come into our Intel Silicon. Oftentimes, they're not optimized, right? So that's what OpenVINO has been doing, were to really compress this model, making sure that it fits into that small size. Could be your small laptop, can be on the cloud. That's what we've been doing, right? We have a portfolio of hardware from Intel. So if you think about Intel, we don't just build GPU, we don't just build CPU, we build a lot of things from the edge to the cloud to the client. So when we think about this coverage, what OpenVINO has been doing is we bring this optimization code, which under the hood is one API, or a lot of these kind of like open source standard work we have done. We distribute across different hardware here. In this case, we even have NPU, which is a new silicon that we provide for high efficiency, low power on the edge devices. And then we started that a long time ago. We call it the VPU. We call it Movidius. So at one point, if you are following us on Raspberry Pi, people plug in those USB key that has actually our NPU built in. And then we can get really good acceleration. I think it was like 10 times faster than the Raspberry Pi for only 5 watt of like power. So that was like one of those accelerators we provide. Why this is important, I think, to us is when you have this cross-platform, cross-OS, cross-architecture, and then cross-models, we have a very powerful tool that you can build many things, or anything, if you can imagine. And remember, my thesis is about having communication with the computer. So you can have use cases that actually were only dreamed about back in those days, become a reality. For example, from computer vision has been very, from old school YOLO, which is almost 10 years ago, we optimize it really good to natural language model that we talk about. Maybe back in those days, we call it BERT as well. We can have now above and beyond with simulation with robots, chatbot we talk about. We can even do voice generation and recognition very well. And then, well, I think everyone talk about this. We can even do code generation, so you can do coding with it. There's a lot of these possibilities are getting explored and also be deployed on the edge as we see every day. So today I lost count how many. Back in those days, we say we have 1,000 of these models. Today we don't even know. Well, we have this huge pool of open source and cross-platform models that you never see. And a lot of time, I think we always think about when you have all these examples, right? This is an open question to everybody here. Where do I put the compute? Honestly, for the many years I work in either before Intel, I was doing my own startup today. Putting the computer in the right place is never an easy question. It's the hard question and never an easy answer to it. So today we figure out some of it because when we build the silicon at Intel, which is what I like my job a lot, it's like I see this new silicon came out and then, hey, there's things that we couldn't believe it was possible before. For example, when we do depth estimation or post estimation, back in those days when you're trying to do it on a CPU, it was very slow. It's not interactive. Today, when you bundle with the NPU, it can be low power, it's real time, it can be simply just like running behind the scene, like in the background for you, while your CPU and GPU are resting happy. So there's like possibility that we didn't know it was such a great idea. And especially background blur. You see my background blur. It's amazing for the NPU because it's not, you can have 4 hours meetings of one because it will use a lot less power and then your battery will be very happy. And think about this compute. Where do I put that? I think this is where I think OpenVINO give you that flexibility. You can switch between this model, that model. And that's where I think the beauty about what we're doing. So I'll take a pause. I'll read some questions that's in the Q&A. Then I'll talk about something really hard. I gotta switch myself to the browser. I'll take a look. I think also we have Ashintosh behind the scene. Actually, Ashintosh has been answering questions. She's from OpenVINO, from Open Edge platform. So we work together, and then thank you for sharing some of the links. I guess we handle the Q&A. I'll keep going first, but I think people always ask like, so like, how do we use NPU? How do we do that? A lot of time, I think you don't have to learn it. That's a beautiful thing about what we're doing. We try to simplify some of the developer workflow. So then we handle the compression and handle the deployment for you. And we put an open source library. So if you really care about performance, like you look at the clock, I have like only, let's say 2 seconds to run this work task. You can actually go into the open source code and figure out where's the bottlenecks are as needed. In this case, with the library we use is called NNCF. This is neural network compression framework. It does amazing work on making the model, for example, doing quantizations. So from 32 bits to in8, and for, let's say, a large language model, we even do down to in4 with different algorithm behind it. Why that's important, I think, there's a lot of techniques which I actually have a lot of tutorial talk about those. So we'll talk about this later in the slide, so you can learn from what I've been talking about here. The key is, with the optimization, is basically means you're only use half your hardware most of the time, or less. Because under the hood, when we think about in8, it's not just the quantization, but under the hood, the silicon has the computation unit specialized for the in8 instructions. So for Xeon, for example, on the cloud side, in8 is a must for AMX to activate it, which is the AMX, the VNNI at that time. ANX, you can also use it for different polling point as well. But for great performance, I think in8 was the great starter, because a lot of time I talked to real developer, they didn't know you're not losing that much in terms of the accuracy. Sometimes you may be doing better or some computer vision task. It's weird. It just happens. Sometimes you actually becomes a denoising to the model because doing the quantization, something happened to it. So you have to measure yourself to what you're doing. But that actually is important for use cases where you may only get like 20 frames per second, and all of a sudden that 2 to 3x boosts you to real time, and then you have a very different product as an outcome. And on the edge use case, you cannot put 3 times more CPU or GPU on it sometimes. You may want to think about this, right? How do you get 2 times more? It's actually a lot more expensive in terms of power, in terms of the cost. So the software, don't ever underestimate. And when we think about this, it's like when we do quantization, when we measure it, especially for YOLO, those type, I think you just have to do it. That's my word to it. Depending on use case, of course, but that's definitely worth your time. And then we provide all the source code here, for example, you can learn, and we've done it and measured it for you. Why that's also important for large language model? We talk about chatbot experience, right? One problem that intrigued me a lot were when we started this a couple years ago, I think almost 2 years ago, when we first looked into large language model, the first problem we dealt with was not the computational problem first, was it didn't even run. It will just blew up the memory, let's say, especially with GPU at that time, and then it stopped running at all. So we start really figuring out the runtime, how to ensure that we're not making extra copies. But at the same time, we will have the first step is, if you look at the Llama 7 billion, right? If you look at the 32 bits, I don't know if a mouse works on top of it. It used 25 gig of RAM. I don't even have any graphics card that closes that range unless I go very high, expensive one. And they don't even work that well for 32 bits. So there's a lot of gaps on what the world is giving you, especially on the model side, and what is deployable. So at that time, 2 years ago, it was an interesting time when we do a keynote. So behind the scene, I was one of the lucky ones to hack it, working with the driver team, working with the runtime team, working with the application team to make one demo to run Llama. And it worked. When the first time I see the computer, the laptop, pumping out, I don't know, 1 token per second or something like that, I was like, carry my laptop, bring it to my wife, and say, oh my God, the computer is talking to me. It's like a human. It's a bit slow, but it's still answering my questions, be able to put a sentence together. I think that's where I think there's a lot of it's not just a hype, it's just it's real. It's actually solving some of those small problems. But if you can solve these well, and then we can collaborate, maybe you can solve big problem. I think that's how usually all these chatbots come together. And that's exactly why we have in4, even different algorithm. This is actually doing asymmetric group 128 different ratio. We want to measure the impact to the model when we compressing them. Why that's important, I think at the end of the day, RAM is RAM. You don't just double it overnight. But if you do right software, do the right algorithm, you can reduce it significantly and without huge performance impact into the model accuracy. I think that's a win-win for what we've seen. And that's why today, when you go to AIPC, a lot of model runs extremely well. It's thanks to the engineering work. If you, however, don't know if your model is working, we did put together a lot of different benchmarks. That's what I love about Intel. Sometimes we are very interesting about like how we approach things. We just did the work and we didn't talk about it a lot. So in here, we have one of the largest database of model. Actually, if you go back into the AIPC thread or some of the model we have optimized, thousands of them for sure. But if you search for just AIPC, you can see how well some of these models can run. So before you fine tune your step or anything, you can predict the outcome, how well this model will run on your machines. I think that's very powerful, especially today. We also work with Microsoft, as I said, right, and with many different partners. Some of the model when we optimize, we actually benchmark for you. So when I say benchmark means we don't just like, hey, it's run this fast, but we benchmark against different parameters. So think about this is almost like a hyper parameter style, right? You just explore all the options in the pool and then look at the impact toward the final outcome. So if you go back to NNCF, the library, if you look at our documentations, oftentimes you'll see even the model we pre-compress, pretty much like we try to see where's the sweet spot for you. So where do you find more of this? You can go to Hugging Face, look at OpenVINO, and then we have a shared repository with some of the pre-compressed model. And that way, then when you start using Intel hardware, you know that you're getting the best software. Take a screenshot of this. This will save you a lot of headaches. Well, at least my headaches. And it will come through very well when you are prototyping, when you are doing any sort of work at Intel or related to Intel, or not even Intel, maybe even ARM platform. So I put together some examples. So I don't just talk, I create a lot of examples. If you're interested in trying what I just talked about, I put together scripts you can double click and it'll run, it'll install, it will download, and it'll run those 3 steps in the bat file. So this is the link to it. Enjoy the code. I did that 2 weeks ago, 1 week ago. It should still work. 1 year later, I don't know. Maybe things will change. But last week I tested and it works extremely well on your laptops. Make sure you have 32 gig of RAM. 32. Okay. And when it runs, it not just run on CPU. This one will run on NPU as well. So when people ask like, would this run on NPU? Yes, it does. When do I use NPU? Depending on scenarios. So in this case, I asked the machine to write a song about AI with emoji. I don't know why, but it worked. It's kind of fun. You can sing with it. So now sky your limit, right? You can be very creative, build your own DJ, sing a song for you. I think it's fun for the kids these days because they will open up their imaginations. And then for my 1-year-old, I got to teach them how to use Gen AI now. The chatbot to do something fun, just like have like an interesting learning experience, but not fully relying on it. I'm just saying, just to have exploration. I think that's where curiosity, right? And if you're interested in what we just saw here, we also build, not just I, as a team of us, build a rec demo where you will see how we bundle this with our partners, like I shouldn't say partner only. It's just like all the community of members, right? It's like anyone that using the tool, like from LangChain, Llama Index, we integrate with them. So then you see our presence of OpenVINO in those large language model tools. And that's important because you don't have to relearn. You can use what you had, but you just have to make sure you enable the right components. And that's going to give you the accelerations. And as a homework, I'm closing in 2 minutes. We also have example on the edge side where you can do agentic workflow. So this is real. Like you can talk to a chatbot locally that you can order some paint, and then I don't know why you want to paint your house today or not, but it's a great experience you can try to see what a chatbot can do locally. This one's a bit slower because we have a lot of extra deep thinking process. Slower means like we use a very big size chatbot, but as the silicon move forward, this is pretty fast already, but it'll get even faster on the edge. Make sure you take a screenshot of this one. And at the last minute, I think I'll do some closing. First, learn the notebooks. That's where you learn 100 examples. And we have an open edge platform that you can use to also learn how to deploy this on the edge. So if you Google open edge platform from Intel, you will see it the GitHub as well. As a closing as a benefit, right? I have 6 benefits here. 2, I think you have to remember. Memory. If you don't have memory footprint that's sufficiently well managed, it will not run well. That's what we learned for the years of trying to optimize it. We got a lot of speed up by learning how to manage our memory. A lot of things are memory bound. And learn how to deploy on different platforms. You never know what people need. Sometimes CPU is busy. Sometimes the GPU could be busy. Maybe use the NPU as you're offloading. So we saw gaming as one example. People want to use the NPU for analytics. You don't want to touch the CPU or GPU. And then having this as scalable, I think use open edge platform, as I said, is very important. This is the key. Please download and try, give us feedback. We open source Getty, which is an amazing tool for training and deploying image model. We open source many great tools like orchestrating different like edge nodes and all that. All the things that I think will take you thousands, maybe hundreds of thousands of hours to build, we put it together into a platform for you. And if you try, you don't like it, that's okay. We'll be here listening, and then we'll make it better. That's what happened at OpenVINO, right? In the beginning, it was a bit rough, but now it's very smooth edge. That's all I can say. If you're really interested in what we're doing in the last minute, contact with us. I think I spent my 25 minutes if I look at my clock correctly. Am I right?
Yeah, thanks. Great talk, Raymond, and thanks also to Ashutosh who followed with the different questions. You know, great talk, really. Maybe I have a couple of questions for you, Raymond. Really, you provided a lot of assets and a comprehensive description of OpenVINO, and but you know, there are different type of industries: small, medium, and large industries, which are spending time and efforts on familiarizing with what you call conventional AI. And so, what's your take on about the messages for these guys, one instead of another, to move forward on generative AI? Why and how these guys should find time to use OpenVINO and the great assets you described?
So I think that's a very good question. Like, it feels like we dropped the ball on the deep learning stuff that we did 4 years ago, 5 years ago, right? All of a sudden, we have this Gen AI, everyone just talk about it. And then what happened to the people already spend a lot of money and time on the deep learning side? I think first is if you're already like doing work that is functional, like license plate detection, we deploy so many of them, we forgot, right? There's a lot of the smart city idea that we use for retail. They work extremely well. I think those, I think we just need to make them better. So when I say better means, oftentimes I see Gen AI could be the one that open up the flexibility of some of these approaches. A famous one, I would say, for a lot of these, again, I'll go back to the YOLO one because a lot of people know it. You need to find your model before it works. You need to do a lot of extra work to ensure the model is tuned to the application. They're not as flexible, right? Flexibility is not built into the architecture itself. So for those use cases, I think people should start realizing that this new wave of this approach can create flexibility. I think this is the step one is, when I think of generative, a lot of things are a lot more tunable. I say tunable, like YOLO, for example, if you do it right, you can automate the fine-tuning step with the agentic approach. And then if on top of that, I saw the one called the YOLO E. They actually combine the YOLO, which is like, hey, you can recognize a dog and a cat. What if you've never seen a banana before? Now what, right? It's like a banana is our track. So we can actually do a prompt injection, prompt based one. They basically combine in the tool called Clip. So then they can now recognize something looks like a banana, and then you can say banana on a table. It's like, it almost looks like a generative AI. It's like you're generating the model, kind of like structure on the fly. but you're using the YOLO architecture, so it's very effective, very efficient. So I see the industry should really think about how can I create better efficiency on some of the older stuff we have done. I don't think they're obsolete. I think they're still serving the purpose, but how can we reduce some of the time spending on that? And then also, I think my title was chatbot. How can we make it communicative, make things more interactive? The whole point is not like, I don't care if it's agentic or not. Can I make a good experience from the user? It's the number one rule. And before, with the older one, they're very limited. Now we can create experience. This is, I think, the key turning point. I never felt so alive when I saw the machine talking to me, right? I think my kid will be like, yeah, Dad, I saw the machine always talking to me. It's like, but I spent the whole 40 years of my life never seen a machine talking to me. So I don't know if people forgot, like, right? So it became a new norm. But like back then, the machine doesn't talk. They just, randomly jiggling on things. I don't know what they're talking about. Anyone use Microsoft Word as a little icon with the cookie thing? Something just never answered my question when I started computing. Anyone use a Microsoft Word at one point? There's a little bit help icon. They never helped me. Not once. But I'm not saying Microsoft is bad. But that time, I thought AI was broken because I asked for how do I do this? It will give me a wrong answer all the time, right? But now we're getting to closer to the right answer, closer and closer every day. Anyway, so that's my take.
That's fantastic. Thanks, Raymond, for elaborating so much. Maybe another question. More related to OpenVINO. Imagine I am a young professional and I would like to leave my footprint designing a generative AI model. How OpenVINO allows me to ease this task?
To start, I think the starting point with OpenVINO is really, again, like OpenVINO is like a step forward to make sure that you get the best performance out. But I think over the year, we changed a little bit, right? We actually have the most number of examples you ever need. If you look at the notebooks, we have about almost 200 of them. And we have our reference design kit. We have another 20 of different examples. I think we built one of the most comprehensive library of things. People, like anything you talk about, you tried it. Most likely you've seen one copy of that on OpenVINO. I think that's like, it's almost like it gives you that library of material where you can dream without, like when I was doing my PhD, I spent 2 weeks just to figure out how to run the CUDA code, just to get it running. Not even just getting it at the performing, it's just get it running. And then I spent another 2 months to get it performing. And then I spent another year to make it actually publishable, right? So there's a line for idea to executable to actual deployable. It takes a year at that time when I started. And of course, there's a CUDA step 0, right? But similar here, right? But with OpenVINO, I think in a couple of weeks, I think you'll be able to pull out some amazing demo. I've got to tell an industry secret here. Every demo I build takes only 2 weeks because I have to catch up with the industry. Like every single thing is 2 weeks. So in 2 weeks, I can spin something out. How? Right? Do I write from scratch, optimizing everything from scratch? No, I have to use the tool. So this is a secret. If you are starting new today, start with a fresh ground where you can be competitive with others. I think that's a great starting point. And that's why we're doing this. You go to OpenVINO notebooks, make a contributor. So we started with 5 contributors, including myself. I have 120, something like that. Be one of the contributor. Do Google some of the code with us. Like we have some student programs. So learn with the expert. There's a lot of things you can engage with us. That I think add me to LinkedIn, you will see it. There's a lot of different posts I made about how to engage with Intel.
Yeah, that's great. Also, that the fact that you mentioned the students programs, and because we need educational contributions for people who are approaching.
Yeah, we've done it for 4 years straight. So, and this is gonna be 5th year next year. So you can take a look at the link, follow us, and then you get paid by Google to work with us. Win-win-win.